You want to have it right from the back?
My name is Vania, and we are the team one with our partners Luis, Sofia, Diana, Seul, and Gabriel. We're going to present you our STEM project, which is NeuWege. Today we will see these topics: the introduction, the research question, the SDGs, objective, justification, theoretical framework, hypotheses, methods, results, 3D prototype, the conclusion, discussion, and the bibliography.
Well, for this project, we wanted to focus on the pollution created by vehicles, since it is a really serious problem that has several negative consequences on human health and on the environment. A lot of different solutions have been implemented to try and reduce our dependency on fossil fuels. However, because of this, the usage of electrical power has increased significantly, which also represents a challenge for the electrical capacity of Nuevo León. So we as a team came up with the idea of implementing certain technologies into a system to further increase their efficiency. So our STEM proposal is a system that is composed by solar panels and by regenerative shock absorbers. And in this presentation, we will explain what they are and how they work.
The research question. So the several stages we had of STEM, we used several research questions, starting with how to add sustainability to cars and how the regenerative shock works and how it is implemented on all these technologies for our transportation. But our main research question to all the STEM is what is the best regenerative shock absorber and how it is composed.
Okay. So we decided to apply the problem that was asked to us instead of in the end, before the theoretical framework, because it seemed to be a part of the problem that we wanted to talk about. That is, that robotics can be applied. We have applied them in our prototype, but mostly for the pollution and energy consumption, it will improve efficiency and grant cleaner technologies.
We have several SDGs in our project. The first one, which is the 7 SDGs, is affordable and clean energy, because our system will help reduce fuel and electric consumption. Next, we have industry innovation and infrastructure, because the project promotes technological advances in the transportation industry. We also have sustainable cities and communities, because managing the electric consumption and the consumption in fossil fuel is a key point to make a city sustainable. We also have responsible consumption and production, as I mentioned. We will reduce this consumption of fossil fuel, and climate action, because by this system we lessen the carbon dioxide footprint in our community.
Our general research objective will be to understand how the regenerative shock absorber works, its components, and how to create one. Specific objectives will be how to connect these regenerative shock absorbers into the vehicle's energy system, and how much energy will it produce, and if the energy produced will be enough to power the vehicle's secondary energy system.
Our justification is that there is a lot of pollution, like everywhere, but mostly it's made from vehicles, and it's a very concerning health risk. And the large amount of carbon dioxide gases in our state puts it on the top 3 states to release carbon dioxide emissions. Furthermore, our state in a few years will all be consumed by all these levels of energy, and we want to reduce that with our energy sufficient.
I was, as my partner Diana was saying, the CO2 emissions of Nuevo León are a real problem that we have. You can really see them in the sky. So few technologies were implemented as more public transportation, the use of solar panels, and mostly the use of electrical cars. With our project, we are looking for that the electrical output doesn't be so strong on the city, and we are looking by implementing in the roof of the car, implementing a solar panel and implementing
regenerative shock absorbers in the wheels.
yes, so that anytime that the car goes through a speed bump or it slows down or speeds up, we can grab the kinetic energy that it causes and use it for our advantage and power secondary functions in the car.
So what is our solution? What are regenerative shock absorbers? So our regenerative shock absorbers will receive the weight and movement of the car through a system of pistons. This movement will set off copper wires, which will cut through magnetic field of iron magnet. This creates a phenomenon known as electric induction happen. All this creates electrical energy from kinetic energy. This electric energy, along with the solar panels, will be enough to power auxiliary systems in a car, such as the AC, lights, radio station, and many more. What differs us from other ideas implementing for reducing carbon dioxide is that our idea implements toolkit technologies into a same system. With this system, we can effectively reduce the consumption of fuel by regenerating with existing energy.
Hypothesis to test is that we can gather enough electrical energy using the regenerative shock absorber and solar panels to feed the auxiliary systems of the vehicles, such as air conditioning, cameras, radios, or more. The dependent variable will be the movement the car produces on the regenerative shock absorber and the light the solar panel gets. The independent variable will be the amount of energy they both make. Now, for this project, we'll be using applied research, since we will be developing a new technology based on previous theories or works of groups of people that have tested or are currently working in similar ideas.
Okay, so this is our result, the data that came out after doing experiments. And since this is a project that is thought to be made in real life physical materials, we have disabled after doing some experimentation. What we can gather from this experimentation that we did on the past days is that even though we can implement these systems into vehicles such as cars, bicycles, motorcycles, it's yet not enough energy produced to power systems like AC, as said in this tables, as notes and capabilities. But we can power systems like light and radio, which is still an important feature that we need in cars. We also need to take in account this is a prototype made with robust materials and it's not going to be perfect. But if we get the support and we get the time to make it even more precise, we will furthermore get the results we want and eventually get to power modular systems in our vehicles.
Great. So as the result explained, like all the tables over there, the other DAT of mathematics is that thanks to the mathematics applied of all the tables you saw over there, we were able to kind of scale what the prototype would be in a normal vehicle, and from that get the conclusion that it can do power secondary actions, but it cannot power something like the AC.
And this is our 3D model and blueprint. This was made on Tinkercad. It uses a lot of shapes. Basically, this is a piston that we're going to use that is really similar to the one made in real life, that is consists on a set of copper coils wired all up on a tube. And this is a piston that moves a magnet up and down, which makes this direct and indirect current, which is transformed by a set of electronics that we cannot represent here because they are not available in Tinkercad and we cannot model them with the time we're given. But here we can see the model of a car that has a light that is a real LED piece by Tinkercad, and it is powered by the system. And this was made in proportion. Here we have the measurements. It is 7 centimeters tall, 20 centimeters length, and 10 centimeters width. So this can be scaled up into a real life system, which will allow us to really see what will be the impact on a real vehicle, such as a motorcycle or a vehicle, a car that we already mentioned.
Hello. Okay, so now we have two sets of conclusions. So from all of these, what we can take is that, first of all, the STEM project helped us with being more aware about the current situation, about the CO2 in our city. Also, that we should really lower our emissions, both of carbon dioxide and help with the electrical output the city is going through. And most importantly, like thinking outside the box and finding new solutions to problems of society. Okay, now for the discussion. This STEM project was really complicated. It was at the end we managed and we got to do all of it. And we really got to learn about thinking outside the box, being creative, thinking about the society, not only ourselves, having new ideas and doing really hard research. And they believe, and thank you.